Thank you for the introduction. Okay, so generative AI, I think it's not the new concept. I think everyone already aware about what is generative AI and what generative AI can do, what are the potential of a generative AI, how we can adopt and use generative AI in, or how do we merge it into the day-to-day business, right? So that's what I'm going to talk about today. Why it is going to transform the business. Why business transformation? Because the data is something which is going to increase day by day. And when the data increases, it's not only the structured data or tabular data. It's going to be all kinds of data. You have unstructured data, PDF, PPTs, documents. So the volume of this unstructured data will grow. Maybe it is 20-fold, it is going to grow month on month in next couple of years. And as the unstructured data increases day by day, the complexity here is how do you query? If you are looking for, let's take something, let's take the invoice which was there on your system a couple of years back or a couple of months back, you want to retrieve it, how much time you are going to spend to retrieve it? You'll just keep searching the folders, right, where the document is, right? How do you access this information quickly? Now, can I use generative AI, right? So basically, you have to give queries. The queries should be parsed in such a way that you can extract the document quickly, retrieve the document quickly. So the generative AI means anything that you generate using artificial intelligence is generative AI. It can be text, it can be images, videos, audios, and it can be a mix of both as well, right? So having said that, what is required to build generative AI solutions? To build generative AI solutions, first thing is data. Now, data, as you know already, the data is not being stored in one place. It is being stored multiple places. It is scattered all over the data lake. It can be having in multi-cloud, you have data storage and all. So first thing that you have to do when you are designing a generative AI solution for your organization, consolidation of data. Wherever you have data, the data has to be consolidated. Even if you are not able to consolidate the data, you have to extract the metadata, at least store the metadata in one place, so that your query should be hitting those metadata and understanding which index to look for. Now, why indexing is required, I'll explain that later. Now, first thing is data has to be in one place. Second is technology. What technology we are going to use? So technology, we have CPUs, GPUs, TPUs. Should I go and purchase more GPUs? Should I go and purchase more TPUs and CPUs, etc.? Right? So having right technology will help you in fetching the information in a right way and more accurate, precisely, and in a faster manner. The next important thing is design. If you will not design it, you cannot retrieve it on time. That's why data, technology, design plays a role, and finally architecture. Architecture for summarization, architecture for reasoning, architecture for question answering, architecture for even thinking about only information retrieval. All are completely going to be different. So I'm going to talk about 3 different architectures: few-shot architecture, zero-shot architecture, and full architecture. So there are 3 kinds of architecture that you can think of while accessing information or retrieving information from your databases or your information systems. Okay? Now, once you build a base solution, the next step is how to scale it. How to scale it, take it from one department to another department, take it from one division to another division, one function to another function. How do you replicate this? So scalability is important. And finally, integrations. Integrations with the customer interfaces, like, for example, giving a mobile application or giving a web interface to the customer so that you can access information quickly, right? That's why it is very important. Now, there are 2 kinds of you can say mode of generative AI, the unimode and multimode. Unimode means only you can give text as an input and you can fetch information. That is called unimode. And multimode means you can provide both speech as well as text, image as well as text, documents as well as text. If you provide multiple inputs to the generative AI models. For example, I think you are already familiar about ChatGPT, right? Can I give the URL of a CSV file or Excel file and tell that, can you summarize can you show me 5 insights out of this Excel file? Now that's your multimodal, where you are giving a CSV file and you are asking the engine to give you insights, right? So what it does, it looks at the data, it summarizes the data because the summarization process is very standard. You can do just univariate, bivariate, multivariate. It's the standard process, and you get the insights. Okay, so and so is X percentage, then this, and XYZ is this, like this, so you'll get all the insights. Now that's basically your multimodal. Now how exactly this magic happens and how it works? Typically, there are 4 kinds of models that are at play in the backend, right? So the first one is called generative adversarial network. When GPT-1 came I think in 2018-19 duration. GPT stands for Generative Pre-trained Transformers. That's called GPT. And after that, so we have GPT-1, GPT-2, GPT-3. Right now, we have GPT-4, which is powering the ChatGPT, right? So ChatGPT, when you enter, you have 2 options, GPT 3.5 and GPT-4. Whichever you want to choose, you can choose. GPT-4, it is powerful. Why it is powerful? Because in the back end, you have, this can take huge text as an input, right? So I'll also talk about that. The input text length also matters in terms of giving the output, right output to you. So the generative adversarial network has 2 different kinds of neural networks. So the neural networks are basically the magic, which is basically retaining the information and retaining the, or creating the memory for this kind of retrieval systems. Apart from this generative adversarial network, the second method is called transformer methods. The transformer methods, that's called pre-trained methods. That means, let's take, I want to teach one computer agent that, okay, you recognize these are chairs. Now the model has learned the chair has a pattern and it has learned it. Now next time you show a chair, the model can easily predict that, okay, this is a chair, right? So that's how the transformers does. So the transformer models are pre-built models, pre-trained models. You don't have to train it, right? And the other 2 variants are basically the variational autoencoders, which is you have encoder system and decoder system. Encoder system translates your input query to a middle layer, and that typically helps you in predicting the outcome, okay? So having said that, the next important thing that I'm going to talk about is the 3 important areas: vision, speech, and text. Generative AI, you can see various applications in these 3 areas. And the most important thing is attention. The attention model, which came, I think there was a paper in 2019, it is called Attention is All You Need. The attention mechanism, it's basically the probability function. So that basically, the function tries to calculate the probability of the next word given there are surrounding words. And based on that, it generates the text multiple times. So this is the attention architecture, which is powering all the transformer models, which is also powering all the, you can see the generative AI models, okay? Now, what to do? How do I explore the journey of the generative AI? The first thing is data. So if I have to create a generative AI application internally within the organization, what do I have to do? I have to first go and collect all the relevant information. The relevant information, let's take, I want to answer, let's take all the financial reports that I have. Anytime, whatever question I will ask, it should be able to tell me the answer. Now, if I have to implement this, what do I have to do? I have to collect all the past historical financial reports and put it in one repository. Then what do I have to do? I have to parse the text, vectorize the text. And vectorization is a process of creating numeric vectors from the data itself. And these reports, basically the tokens or the words are called features. These features and the combination of words are called basically embedded features. So typically it is known as word embeddings. So word embeddings I have to create from the raw data. The raw data will be parsed using any standard, I'll talk about the advancements also, recent advancements. You don't have to do it from the very beginning or from the scratch. There are various tools that has evolved or that have been evolving since last typically 8 to 9 weeks. Today morning I saw a tool called Galileo. What it does, you have a pre-trained model, you want to fine-tune it, you don't have to go to cloud and get the GPU and upload it, then process it. You just upload it to the Galileo platform, it gives you the slider, you just drag and drop. So simple interface. to play around the existing LLM models so that you can create your own solutions, right? Initially, when GPT, or I would say ChatGPT or OpenAI, when they started training or building these LLMs, they manually has to go through each and every website, scrape the text, clean the text, parse the text, create embedded features, then put it for deep learning training that they used to do. Now you have tools like, there are word embedding tools. You have a document, you simply upload and download the Excel sheet that gives you the word embedding features. You don't have to do anything manually. So these tools are evolving, and many more such tools will also come in future. So the first thing is, the word embedding that I'm talking about, that is basically context. So context is relevant, and if you don't have context in your data, even if you give a better prompt, it is not going to work. So prompt or input that you are giving to these LLMs to get the right answer, you need to organize the data properly. That is why contextualization is important. So first you get the data, scrape the text, create embedded features. As many embedded features as you can, you should create. Now that's basically your contextualization. Once your contextual data is ready, then you can go for training. Then you have to think about, okay, what kind of a model I will be using, right? So there are various models. So you can use maybe BERT, XLM bot, Robota, XLM small, XT5, Pegasus, and there are so many models out there. Now what kind of model? You can choose that. But first thing, you contextualize the data, okay? Now another important point here is, should I include all my functions data together while creating an LLM for my organization? The model may get confused. Finance, HR, operations, I can keep it separate. One LLM for each function. Then you will get better accuracy. Your context will not disturb or hallucinate the model. You can get better accuracy. So in such situations, what you have to do, function-wise, if there is a clear differentiation, so let's take, there is operations and HR, both are completely different. The documents are different because the words that is being used in operations are different. In HR, it is different. So I should create two separate corpuses. Two separate corpuses means the collection of documents, right? So the contextualization to the use case is important, and contextualization of various functions are also important. If you mix it, there is nothing wrong in it, but your answers will be again convoluted. It's very difficult to differentiate, okay, what it tells me, right? So that's why once you have the contextual vectors ready or embedded vectors ready, the next step is going for your exploration of technology. What kind of technology I'll be using? Then you have to go for integration. Integration, you need to create a front end, and then you have to integrate the backend APIs, and then you get the input query. Now here is the challenge. The users, they will intentionally try to fool the system because they would want to create disturbances, because that's a nature. Like, I mean, we want to break things, right? So how do you prevent such kind of malpractices or such kind of intents, malicious intents? How do you prevent them? What inputs to be taken? What inputs not to be taken? You need to have filters there. So you need to have a screener words. So like you can put a list of abusive words, list of unacceptable, unprofessional words. So these collections or corpuses that you need to create, and you need to put those things as filters, so that when user is entering the text, you have to first do a screener, remove these words, then the rest of the words you have to pass it to the model, so that your model understands the right words and right context. So you need to have this mechanism when you are creating the front-end solution. And finally, you just deploy the solution. And obviously, the next thing is about tracking and monitoring the models. Now, the next thing is the use cases, right? So the use cases are classified into 3 categories, I would say. The first category is text generation. In text generation, what do we do? Now, I will say, can you write an application for X department for something Y? Now, the person spends 5 minutes or at least 10 minutes. A proficient person maybe takes around 15 minutes, 10 minutes or 5 minutes to write an application, right? You ask the LLM, you get it in 30 seconds. So that gives you productivity boost. Any kind of a text generation, it could be writing an application, writing a product review, responding to a customer complaint, right? So how you will train the LLM to respond to customer complaints? When you are receiving multiple customer complaints, let's say for any product or any services, you are receiving every month probably few customer complaints, right? And you are classifying it. This category of a customer complaints relating to services, this is relating to price, this is relating to people, this is relating to something else. You have the classification ready, right? And you have a standard response to each of the categories as well, right? Now, I have the responses, I have the questions or the complaints. Can I train the machine that if this kind of complaint comes, this is your standard response you have to provide? Now, that's where your pre-trained models comes in. You get the pre-trained model, get this data, embed this data with the pre-trained model, have one round of training and fine-tuning, and then it is ready. Next time you get a customer complaint, you provide the standard response. Now, the standard response is not acceptable, they'll go to the next level. Standard response, they are happy, done. There is no manual intervention there. That's how you will reduce the manual interventions when you have repeated need for addressing the customer complaints or queries, etc. Similarly, the FAQ documents. You are trying to open an account or closing the account or shifting the ownership of the account. You are reaching out to the bank, let's take. Now you are asking this FAQ, right? Frequently asked questions you have. Now, can a LLM answer all those questions? Yes, why not? Now, this has to be accurate. You cannot just say, okay, go to this URL and do this. No. People don't have time to go to the URL and search for information. Asking questions, you answer it, right? Don't redirect to another URL. So like this, you have to find out the use cases. What all use cases are, or what are the use cases within the organization that you find that falls under the text generation, where you have to respond to someone. Something is asked, something is being asked to you, you have to respond to them, right? That is your text generation, right? So it can be a customer service agent, it can be marketing person, it can be salesperson. There has to be a standard response that you are trying to provide. That's why the text generation. The next part is text summarization. You have received, let's take a legal contract. Can somebody tell me what it is? Can you summarize in 2-3 lines what it is? I don't have time to go through all those legal contracts, right? Terms and conditions documents. Who reads those 20-page terms and conditions document, right? We don't have time. But can I have a system that can summarize it and tell me that this is what it is? You don't have to worry. This is all good. Agree, proceed, right? That's why you need a document summarization system. Can the LLM be a document summarization system? Yes, you can. Can I use a pre-trained model? Yes, I can use it, right? Now, how do I operationalize it? You have to build a front end. You have to take the pre-trained model, put it in a Docker object, get it to the cloud, create an API as a service, and expose it to the front end. You give a query, it takes the query, it makes a call to the model, generates the inferences, renders it on the front end. That's it. This is the pre-trained model, right? Similarly, like text generation, there can be audio classification you can do. Audio classification is, for example, automatically recognizing customer's voice when the moment they say, hello, can you help me? Or I need something, right? When customer just speaks, you have to do that authentication and authorization online. You don't have to ask questions, okay, what is your name, DOB, etc., what was your last transaction, etc. You don't have to ask multiple questions and spend 30 seconds on customer authentication, right? So can I recognize the customer at the first instance? Because historically, you have the data, right? You have it, this customer must have called, you have the historical data, put that data, train the model, get the model ready. Now customer speaks, you verify it, that's it. The next level is understanding their past queries. So relate back to the past query, what was the response given, and just proactively tell them that, okay, this is your pending question or query, I can help you. So customer will feel delighted, right? He don't have to repeat the same thing, right? This is the same problem I called yesterday, then day before yesterday, then it's not solved yet. You don't have to explain all those things. You have to proactively understand those things, right? So that's why audio classification, similarly image classification and video classification also, these are the use cases where you can introduce LLMs. And for this, There are two options. Either you can take the pre-trained models or you can build your own model, right? And what are the options? How I can proceed? So that's what I will discuss in the next couple of slides. So to summarize, the text generation is like open-ended text generation, which is like, oh, tell me a story, or can you generate a design for me? I want to build a 3-story building. Can you can you send me a design? Yes, this is the standard practice. There are multiple houses, 3-story buildings, and you want to create a design. Okay, here is the design. So such kind of things where there is a repetitivity or repetitive, the things are which is repetitive in nature, you can generate using large language models or LLMs. Similarly, a couple of other things like content generation. You want to post 3 things on social media. Let's take Instagram post, Facebook post, and LinkedIn post. What should be the text? You don't have to think much. This is an event I want to announce to the world. I want to put it on LinkedIn and Instagram. Okay, done. 30 seconds. You get the text, post it. Finish, right? So I don't have to think much. So that provides a lot of productivity gain to us when we go ahead with LLMs. Similarly, other things like the minutes of the meeting. Automatically generating the minutes of the meeting, that is basically your text summarization. Whatever conversation happened, the model is summarizing it, right? That's your text summarization. Similarly, code generation or script generation. There are so many codes out there over the internet. So you have Stack Overflow, you have various other coding platforms. And standard, you want to write a for loop, which runs for 2-3 logical checks, standard. So a code can be generated, right? So these things provides a lot of productivity gains, and this helps. And who are the players into this generative AI market right now? So these are OpenAI. I think they started in 2012. OpenAI started scrolling the Wikipedia data, and they scrolled few other websites as well. 60% of their training data was Wikipedia data. And it matters, like what kind of online information you are scraping, that matters. If you scrape a lot of novels, storybooks, etc., and you ask questions like business-related questions, your model will fail. That is why in the very beginning I said contextualization. The LLM that you want to build around the data set, that should be, your questions should be on that only, right? So you cannot ask novels-related questions again on business and vice versa. You can't do that. That's why, so OpenAI, initially the response was not that accurate because I think they trained a different kind of data set, but over the years, they have received multiple inputs from various people, and when people started using these things, and that's how they made it better. The recent players are, I think the latest state-of-the-art model is called the Falcon. Falcon's accuracy is much ahead, and they have much bigger model, and Falcon is very fast also and responsive also. Now, thinking about the process, so there are 2 kinds of model, as I said before, pre-trained and pre-trained open models. Pre-trained means ChatGPT-4, let's take GPT-4. Can I take GPT-4, download it, retrain with my data, and again put it back? No. This is pre-trained model, freezed. Pre-trained open. Can I take GPT 3.5 as a foundational model? I will use my data and retrain it and put it back? Yes, I can do that. So that's why you need to understand first whether it is an open model or it's a closed model. And pre-training cost and time. For pre-training, I have to go for GPU or TPU. GPU, how many GPUs? What is the duration of those GPUs, etc. that I need to also understand. And these decisions has to be made when you before you start building an LLM. You have to decide all those questions, right? This is important. The next thing, so I talk about 3 different kinds of architectures. This is called zero-shot architecture. In zero-shot architecture, first thing you will be getting is the user will be obviously giving the prompts. You will get the pre-trained corpus. Corpus is already built by someone else. I'm just using it, giving prompt and getting response. Here, the accuracy is very, very low. You cannot trust the results. And this is a limited, and there is no cost attached to this. Is free. There is no cost. Second, this is called the few-shot mode, where you have a pre-trained corpus, you have your own corpus, and you are mixing your corpus with pre-trained corpus to generate the responses. Now here, when you provide your corpus, you can have few Excel files or PDF files, you can pass it. But if you have tons of PDF files and you want to put it back here, it will not work. So this has a limited capability where few shot mode only can allow you to take few documents, PDF, Excel, parse it, get the context vector, create embedded features, and then attach it to pre-trained corpus, again do a fine tuning and put it back and generate the responses. The third one, this is the retrieval mode, which is very, very powerful and it has no limitations. This is very, very accurate, but the limitation here is cost. You have to incur a lot of cost to train such kind of models. This is best, this architecture is best, but here in this case you have to incur cost. You have to train the model on large scale GPUs. That's why it is important. And here your prompts are also getting created as embedded features. Your data is data corpus also created as embedded features. Both the prompt and data corpus, it goes to the vector data store. Why vector data store? Because it is fast to do an index-based search. And once you do index-based search, then you can attach this index-based search to your data corpus to generate your responses. Now, coming back to again the use cases side of things. So if I just look at the productivity boost is something which is definitely available. And if you can build LLMs based on your own data, and this is definitely going to help organizations and in many functions. This is definitely going to help, okay? So challenges are there, but these challenges, again, it will go, automatically it will go. And some of the challenges are like, for example, inclusiveness of your training data set. What does that mean? That means if I'm training a partial data, like just simple example I'll give. There is a news article which is 3 pages, right? And I will only give 1.5 pages to the model to get trained. The remaining 1.5 part is not known to the model. When I ask questions, it would be partial, right? Because the full context is not known to the model. That is why the inclusiveness of training data set means if you are training a model to do something, give the data that is all the data that is relevant, give it to the model. Whatever you know. If you don't know something which is beyond your horizon or the data is not available, you can't provide. But if you have the information, provide the full information so that the context understanding of the model would be better. Data privacy and security also a concern because personal data, financial data, you should not put it. What is the concern? The concern here is if it is going to the foundational model, it is a concern. If it is going to the middle layer, generate inferences, and this data is again getting deleted, which is okay. But the moment this data goes to the foundational models, the developers use this model, use this data to train the model once again, then it's a problem. That is why data privacy and security concerns are there, but some people, they're creating products, the layer will come, that eventually will come. The other information is like, I can say the long input text. That's a problem. You can say, send me 20-page, maybe a insurance policy or terms and conditions document, send me 20 pages. It cannot generate 20 pages. Some models, they only, largest model I think is 2048 input text only it can take. 2048 words only it can take as an input. More than 2048 words, the model will not accept. Now, 2 days back, there is a model, I think this is a Llama 2, which takes 10,000 words. 10,000. It's just 5 times of 2048 words. That takes as an input. So day by day, these models are becoming more powerful. The number of parameters that it is getting trained, it is also becoming powerful. And it will evolve. It will evolve, and that's the new normalization, new normal, like I can say. Many companies, they will be going ahead with generative AI. Many companies, they will be producing technology that will enable you to use generative AI. And many companies also, they are creating middlewares where you can take pre-trained foundational models and you can take your own data, merge it, low code, no code, drag and drop, and you can generate your own LLM. I think that's going to be the new normal. Thank you.